welcome back. This video, we're going to be working with Visual Basic and arrays. Just as a reminder, an array is a group of data items where all the data items have the same, every item in the array has the same data type, and they're going to be referenced using the same variable name. They're also stored in consecutive memory locations. So down here at the bottom, we have conceptually what an array might look like. So let's pretend this is an array called ages, and these 5 values in the array correspond to ages. This is an example of when we might use an array, when we have a set of values that are all related because they're referring to the same type of data. So we have our array down here again, but we've added a little number beneath each one of them, and that's customary to write the representation of an array in this way. Those numbers represent what's called a subscript, also called an index. I tend to use the word indexed, but the two mean the same thing. And an index is really just the position number of a value within the array. So this first value has position or index 0. The second value has position or index 1. So since we always start our indexing at 0, the last item in the array is always going to be 1 less than the size of the array. So if we have what's called a 5-element array, we call it that because each one of these boxes represents an element. So if we have a 5-element array, the index of the last element in that array will always be 1 less than the size of the array. So in this case, it would be 4. An upper bound of the array is nothing more than the index associated with the last element stored in the array. So if you have a 5-element array, the upper bound is 4. The lower bound of any array is 0 because indexing always begins at 0. So to use an array, just like other variables in Visual Basic, you first must declare the array. And to declare it, you have to specify its name, the type of data that's being stored in the array. And there's really 2 flavors of declarations for arrays. One creates an empty array. It creates an array where we're not populating it with values yet. We would do this if our intention was later in the program to perhaps let the user provide the values for the array, or we read it from a database or some other possibility such as that. So there's times where we want to declare an array without initialization. We just want to create it. So when we do that, we specify dim, the name of the array, so it looks very much like a regular variable declaration. The change happens right here. After the name of the array, we have parentheses. Inside the parentheses, we have the upper bound of the array, close parentheses, and then as, and then the data type that this array is going to hold. So if this is an array of integers, this would say as integer. Probably the only thing that students have run up against that could be a little bit confusing here is this concept of an upper bound in between parentheses. Our knee-jerk reaction is going to want to be to put the size of the array in between those parentheses. We have to be very careful because unfortunately Visual Basic departs from the pseudocode C and Java languages. So when we saw pseudocode last week, we were specifying the size of the array in between square brackets. Now we're using parentheses instead of square brackets, and I'm telling you to use the upper bound. So we have to do a little mental adjustment. The upper bound is always going to be 1 less than the size of the array. So for example, if I want to declare an array called city populations of size 3 to hold integers, I would say dim city populations parentheses 2 close parentheses as integer. So the same thing down here. Here we're creating an array of size 3 called cities that holds strings. So when you declare an array without initialization, in other words, you're not providing initial values, Visual Basic will go ahead and populate any array that is holding numeric values with zeros, and it will populate an array of strings with all nulls, which null is like a nothing. It's like a zero value for strings. Now, if we had values ahead of time that we knew we had in our hands and we wanted to use to initialize the array, we could certainly do that. There is a second way to declare arrays. It begins in the same manner, dim, the name of the array, but notice the empty parentheses this time. We will not specify a value in between. As data type, that's all the same. But here comes our initialization syntax. We're going to put an equals sign, curly braces, and inside the curly braces, a comma delimited list of values that we want to populate the array with. So data item 1 here will be used as the first element in the array, data item 2, the second element, and so forth. So they're arranged in the same position as they will be placed in the array. It is very important to not put a number in between parentheses. Sometimes we forget, but if you're providing a list of values, the compiler will throw an error if you try to put a number in there. So just be aware of that. So let's look at some examples. Here we're declaring an array called city populations of integers, and we provide for it a comma delimited list of 3 values used to initialize this array. So it uses this list to figure out how large to make the array. And since there's 3 data items in the list, down here on the left, you're looking at the array that would be created from that statement. Creates the array of size 3 and initializes it with the integer values. The same goes for this example. Here we have the syntax to declare and initialize an array called cities with Chicago, Detroit. Now notice each of these 3 values has double quotes around it. That's important, remember, because when we're working with string literals, we must have double quotes around the values. So this statement here would create the second array down here on the right. We're going to switch gears. I'm leaving the slides, but please remember to cover all the slides and book reading each week. I am going to switch gears though and take a look at some examples in Visual Basic. So I went ahead and I created a small program that at this point has 2 arrays. And I used the syntax of the array declaration that included the initialization of the array. So let's look at the first one. Line 4 will create an array of size 5 named names. It's actually called names. And it's going to store 5 string values. Now, this flavor of declaration is the one that accepts a list of values to initialize or pre-populate our array with. So note the empty parentheses and note on the right side of the data type equals and then our list of comma delimited values. So now if I run this program, it really doesn't do anything yet that the user can see, but we did create and initialize this array called names. We also declared and initialized in the similar way an array called ages. I made a little mistake here. I'm going to go ahead and fix that. This should say integer. Very important that our data types match up. Let me go ahead and stick my option strict on here. That's always a good thing to have on. Option explicit is on by default, but I'll go ahead and stick that on too. That'll help me be a little more cautious with my data types. It'll catch errors with data types. So I'm going to go ahead and declare an array called ages of type integer, and just like above, I'm initializing that array with values. Notice this time we did not put the quotes around it. That's because we're not working with strings, we're working with integers. So once we have an array or a couple arrays, we can work with them. We can output the values, we can store them to a database, we can make calculations. So for example, If I wanted to loop through using the for loop and print out every name in the list of names, I could do that. I could, maybe I'll first write a little message that said list of names. And I'm also going to declare a variable up here called index of type integer. That data type of integer is important because I'm going to use index to not only as my loop control variable, but as my way of referencing every element in the array. So if you recall from the last video where we were working with arrays in pseudocode, we can loop through arrays. That's one of the very powerful features of arrays, that we can loop through and access every element in that array using its index. So let's see what that looks like. We always want, well, not always, but most frequently, we want to start with the first element in the array, and that's index 0. So we'll say start index at 0. And in a 5-element array, the upper bound is actually 4 because it's 1 less than the size of the array. Now I wrote 4 here, but please keep in mind I could have created a constant up here called size, referenced size here. In the next example, I'll show you another thing that we can do instead of hard coding 4 that is most frequently used. And inside of the loop, let me go ahead and display. Now recall, this write line will be executed 5 times, 1 for each value of index from running from 0 to 4. So if I write a statement such as, or a partial statement here where I say names subindex is how we would read that. This is going to access, this is an array access expression that's going to say, go to the names array and look up the element at the index value of whatever index is equal to at this pass through the loop. So the first time through the loop, index is 0. So this is going to access name sub 0, which is Talisha, and it will output Talisha. Recall the for loop increments index, our loop control variable, to 1. The next time through, it's going to access names sub 1, which is John, and it's going to continue in that way. So let's go ahead and try this out. There we see our list of names. And maybe I'll add a couple empty spaces here. Get me a little bit of vertical space in between, because I'm going to now loop through and print out all the ages. Now this time I could certainly use a for loop again, but just for argument's sake here, I want to remind us we can also loop through and use a while loop, a do while loop. There's no reason why we can't. Let me go ahead and create that here, and we'll take a look at it. I'm going to do a little copy paste. Okay, so just a reminder, for loops, do while loops, any of the above is fine for looping through an array. For loops are often the most compact and straightforward way to do so, but just as a reminder, you can use a do while loop. I'm going to go ahead and set index back to 0. That's a very important step before I use that same variable to loop through, no mistake there, let me go ahead and fix this, my ages array. So I can reuse a variable. That's very important to understand. Variables values can be updated and changed throughout the execution of a program. Here we're reusing it by setting it to 0, and we're saying while it's less than or equal to 4, and we can do that because our ages array is also size 5. This will bring us through the value of 4, and once index becomes 5, the loop iterations will stop. Inside the loop, we're doing the same action, but this time we're referring to the ages array. So the first time through ages sub 0, we'll refer to 10. The second time through ages sub 1, when index is 1, we'll refer to 49. Now, because we are using a do while instead of a for loop, remember that it is important to increment the value of index each time through the loop. This can be written index equals index plus 1, or index plus equals 1 would have worked as well. So let's give this a try. Now we see our list of names and our list of ages. And that works very well. Now, if somebody, my manager told me, well, that list of ages corresponds to the list of names. They're parallel arrays, they're related. And I really want you to write the names and the ages right beside each other so that, for example, it says Talisha 10, John 49, where Talisha 10 is on one line and John 49 is on the other. So if we had a relationship between those two arrays and we knew they were parallel arrays, what I could do is maybe we'll go ahead and get rid of and clean up a bit of that second loop and say list of names and ages. And instead of just writing out the name, maybe I could say name, such as Talisha, age, and then reference the ages array in the same position. Since they're parallel arrays, we're being told that the first age in the ages array corresponds to the first name in the names array. We would need to know that that is the case before we could make such an assumption. So if we did know that to be the case, we could do something like this. It would say Talisha. Maybe we could stick a label at the front of here as well, where it says name Talisha and then the name, and then another label age followed by the age. So notice that we are using the concatenation operator here to join together all these little pieces, and we're using the same index value to reference both the element at names and the element in ages at the same position. So let's give this a try. So now we can see our list of names and ages. We see the person's name followed by their age. So we certainly can do that as well. I'm going to switch examples here. Now in this case, both of our arrays were initialized to values. Let's look at an example where we're creating an empty array. So in this example, I'm creating an array called exam scores of size 5, and exam scores is empty. It's actually, we do not have an equal sign, we do not have a list of values, so therefore it is going to, behind the scenes, just stuff zeros in for every element in this array. Now it is a size 5 array, don't be confused. Remember, this 4 in between is an upper bound, meaning that it is going to go up to index 4 since indexing starts at 0. That's actually a size 5 array. Now this time, I wanted to get the exam scores from the user. So I did not specify a list of exam scores. Instead, I created a variable exam score string, which we've used quite a bit, this strategy of reading in the user's input as a string and then converting it to the required numeric data type, in this case type integer. So that's really more of a work variable we just use temporarily. And this is our index variable, and just to provide a different name this time, I used X. I think one or two of the examples in the text use X, so just so you know, this variable really can be named anything. In the last example, I called it index. It's going to control our loop, and we're also going to use it to refer to elements within the array by the index. So we created a loop that starts at 0. goes to 4. This is the same strategy we used last time. But notice instead of outputting the values in the array, which really wouldn't be very interesting at this point because they're all zeros anyway, we are going to ask the user to specify an exam score value. And this is nothing different than we've done in the past. We're getting an exam score value as a string. We convert it to an integer. Now, the interesting part is instead of assigning it to just your standard old integer variable exam score, which would be very limiting in our case because we'd have to have 5 different variables for that. Instead, we use the expression exam scores sub x. And remember, x is going to start at 0. So the first time through, this expression is going to read exam scores sub 0, which is going to refer to the first element in the array. And it's basically saying set the first element in the array equal to whatever the user provided to us and has been converted to an integer. The second time through, x is 1. So this expression will be storing the value in the second element at index 1 of the array. So by iterating through 5 times, it's going to populate our exam scores array with values. So therefore, the second loop, which really looks identical to this first loop, is going to loop through and print out all of those exam score values. So here we get our prompt for exam score. So we can put in, I don't have a lot of data validation in here, so I could easily, put a letter in, for example, and cause mayhem. So I'm going to be careful at this point before data validation to put in all numeric numbers. And there we see your exam scores are the following. This is the second loop at work, looping through and printing out all our values. Notice we're using the same strategy we did in the last program where we're referencing exam score sub x, where x represents a number 0 through 4, starting at 1 and going all the way through 4, incrementing by 1 each time through the loop. Now, if we didn't want to print out the exam scores, but instead maybe we wanted to calculate the average of the exam scores, I could easily modify this program to keep track of a sum of exam scores. And I'm also going to create an average variable. I'm going to be careful to make it a floating type. In Visual Basic, that's either single or double, so I'm going to go ahead and make that a double. And with each new value we get from the user, I'm going to update sum. And we've seen this before. Sum is an accumulator variable, and I'm going to set it to the new value, the new exam score that we just received from the user. And remember, that's represented by this expression. So this is going to say whatever that value was, add it to the sum and update the sum. So after the loop, we can very easily calculate the average. Take that sum and divide it by, now this time we will say 5 because it is a size 5 array. We've collected 5 exam scores, and we'll go ahead and display that value for the user. So there we see the average of exam scores is. Now this came out to a nice tidy number of 87.8. Just so you know, to prevent numbers like 87.8888888, you can use the math.round feature. You type math.round parentheses, the variable you wish to round, comma, and then how many positions after the decimal point you want to keep. So this expression says take average and don't modify the variable, but just before you display it, take that value in memory, round it to 2 positions, and output it. So in the event we would get a little bit of a messy number there, that will round us out nicely. One thing I wanted to show you about this 4 and this 5, which are sometimes called, magic numbers. There's no real explanation of why we used 4 and 5. Is that we can use a property called length that exists for arrays. So for example, down here with the average, I can say sum divided by exam scores dot length. That's a better expression because dot length of any array will give you the size of the array automatically. So if down the road we change the size of exam scores up here, we wouldn't also need to come down here and make any changes. This will automatically evaluate to 5. And we can do the same thing here, exam scores length. The only thing is if we run this as is and we populate our values, it'll run correctly at first. But then we'll eventually get index out of range, exception index was outside the bounds. That is because we went too far. We went from 0 to 5, and in a 5-element array, we need to do 1 less than that. So exam scores dot length minus 1 is the upper bound to use for this for loop. We can try it again, and it's going to work successfully for us. There we get our exam scores.